Today we're going to be talking about conversions, both metric and English, using the same method, dimensional analysis. We're going to start with the metric system today. So the Système d'International, or the SI system, is also known as the metric system. We use this in science because it makes it easier to communicate findings with other scientists throughout the world who all use the metric system, except for us. And it's easier to convert because it's based on units of 10. Okay. Our base units in the SI system are pretty simple. Length, which means the distance between any 2 points, we're going to measure in meters. We're mostly in our class be using centimeters when we use a ruler, or when we get into bond lengths, we might even be using nanometers. Volume is the amount an object takes up, and so we're going to be using liters as our base unit for volume, though we'll be mostly using milliliters to use our chemicals less. A good conversion to remember is that 1 milliliter equals 1 cubic centimeter. So if I had a cube that was 1 centimeter by 1 centimeter by 1 centimeter, length times width times height, that's 1 cubic centimeter. If you were to fill that with liquid, it would have 1 milliliter. So this is a way to convert between solids and liquids that are the same volume. 1 milliliter equals 1 cubic centimeter. Mass is the amount of matter in an object, and our base unit is the gram. Occasionally we'll use milligrams or kilograms, maybe even micrograms, but for the most part we're going to be using grams. Temperature is the amount of average kinetic energy between the particles, and our base unit is Kelvin, though we don't have any thermometers that measure Kelvin, so we'll be using Celsius and then converting it to Kelvin when we need to, and that's a very simple conversion of adding 273. Remember that water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. We will not be using Fahrenheit at all in this course. Our last unit that we occasionally will use is time, which, as you can see, I had a hard time defining, so I wrote it as time. And our base unit for time is seconds. Our metric system is based off prefixes and these base 10 units. So the table below is on your reference sheet. You'll see that you have the prefix, its symbol, but in the first column you have the factor. The factor refers to how many base units are in that prefixed unit. So for example, in 1 kilometer, there is 10 to the third, or 1,000 meters. Alternatively, if you go down to micro, for every 1 microliter, there is 10 to the negative 6th liters. So we have to remember that those factors refer to one of the base unit, one of the prefix unit equaling the factor goes with the base unit. Okay, we're going to practice that here in a few slides. So we're going to be using dimensional analysis, which is the way I'd like you to set up all of your conversions. It will make your life easier to get into this habit, because when we get into other units where we use stoichiometry, having this skill is important. Okay, so we're going to start with drawing a T-chart. We're going to place the given unit in the first box. We're going to place the same unit catty-corner down. This allows us, for when we divide, to cancel out that unit. Then we'll put our desired unit on top, followed by our conversion factors, and every T-chart works the same. We're going to multiply across the top and divide by the bottom. So our first example is how many seconds are in 90 minutes. Step 1 is to draw a T-chart. Step 2, we're going to put our given in the first box. Because our given unit is in minutes, we're going to cancel minutes on the bottom. Finally, we're going to put our desired unit on top. Knowing that 1 minute equals 60 seconds, our units can have numbers, and now we will multiply across the top and divide by the bottom. 90 times 60 divided by 1 is 5,400 seconds. Our second example is a metric example. If I have 275 millimeters, how many meters is that? Again, I'm going to have a T-chart. I'm going to put the given in the first box. My unit that I start with was millimeters, so millimeters goes below to cancel, and meters goes on top. Remember that factor, for every 1 millimeter, it is 10 to the negative 3 meters. So multiplying across the top, 275 times 10 to the negative third power gives me 0.275 meters. But some conversions require more than one conversion in that. So how many inches are in 3 yards? I'm going to still have a T-chart, but it's going to be a bigger T-chart. I still put my given in the first box, 3 yards. I'm going to cancel out those yards below, but I don't know how many inches are in a yard, but I do know how many feet are in a yard. Then I can cancel out my feet and then get to inches. Using 2 conversion factors, I know that 1 yard equals 3 feet, and I know that 1 foot equals 12 inches. Multiplying across the top, dividing by the bottom, 3 times 3 times 12 is 108 inches. Our last example is another metric example. How many nanograms are in 0.0341 milligrams? I'm going to have my big T-chart with my given in the first box. Because I'm starting with milligrams, milligrams goes below to cancel. But I'm going to go to the base unit so that I can use those factors. Then, using my base unit to cancel, I can then get to nanograms. Remember that 1 goes in front of our prefixed unit, the milligrams, and the factor goes in front of the base unit. So there's 10 to the negative third grams in 1 milligram. Just like for every 1 nanogram, there's 10 to the negative 9 grams. In this scenario, I'm going to take my given value, 0.0341. I'm going to multiply times 10 to the negative third, but then I'm going to divide, it's on the bottom, by 10 to the negative ninth. As I do that, I get 34.1 nanograms as my answer. I hope this was helpful.